They built engines so tough they could outlast the equipment that carried them, and so powerful they became the heartbeat of American industry. But here's the shocking truth. Detroit Diesel's greatest strength, their relentless pursuit of two-stroke perfection, became the very thing that destroyed them, including having to pay a whopping $83 million in combined EPA fines. This is the story of a company that was literally too hot for its own good. In 1938, General Motors formed the GM Diesel division, what would later become Detroit Diesel, kickstarting a two-stroke dynasty that would power everything from military vessels to mass transit. What they created wasn't just a product line, it was a mechanical dynasty that would dominate American industry for over half a century. The foundation of this empire was the Series 71, introduced in 1938 as a modular masterpiece that could be configured as inline or V-type engines depending on the application. The genius wasn't just in the power, it was in the modularity. Whether you needed a compact 371 for a generator or a massive 16 V71 for a ship, the basic architecture remained the same, creating parts commonality that made maintenance economical across diverse applications. The Series 71 earned its reputation in the crucible of World War II, where these engines powered Navy patrol boats, landing craft, some variants of the Sherman tank, and a wide array of other military vehicles. The military demanded engines that could run in desert sand, Arctic cold, and saltwater spray, conditions that would destroy lesser power plants. The Series 71 not only survived but thrived, creating a legend of indestructibility that would define Detroit Diesel for decades. What made these engines special wasn't just their durability, it was their fundamental design philosophy. The two-stroke cycle meant power on every revolution instead of every other revolution like four-stroke engines. This gave them greater power density, delivering more output per pound of engine. The roots blower wasn't optional, it was integral to operation, forcing fresh air through intake ports while scavenging exhaust gases. The unit injector system was another stroke of genius that demonstrated Detroit's commitment to serviceability. Each cylinder had its own injector combining pump and nozzle in a single replaceable unit, so when one failed, it could be swapped in minutes without touching the fuel system. While the engine also used dry cylinder liners, which required full disassembly to service, the overall design still reflected a rebuild-over-replace philosophy common to Detroit Diesel's rugged, long-lived reputation. The deep skirt block construction featured 7 main bearings that distributed loads evenly across the crankshaft, while the forged steel crankshaft itself was designed to handle extreme stresses without failure. The cylinder heads were individual units that could be removed and serviced independently, making valve work and combustion chamber maintenance straightforward. After the war, the Series 71 family expanded into civilian applications with the same military-grade toughness. Commercial fishing boats relied on 6 71 engines that could run for days in saltwater spray and still start reliably. The engine's tolerance for harsh conditions made them popular in applications where other power plants would fail, from Arctic construction projects to tropical marine operations. Tugboats used 8 V71 engines that could handle the constant load changes of harbor work, while powering hydraulic systems for winches and fire pumps. The two-stroke design's immediate throttle response was perfect for tugboat operations, where precise power control was essential for maneuvering large vessels in tight quarters. The engines could idle for hours while positioning barges, then instantly deliver full power when needed. Construction equipment operators discovered that Series 71 engines could handle overloads and abuse that would destroy other power plants. The conservative tuning and robust construction meant that even when pushed beyond their rated limits, these engines rarely suffered catastrophic failures. The mechanical fuel injection system was tolerant of contaminated fuel, and the simple governor design was virtually bulletproof. The engines were designed assuming they'd be rebuilt multiple times over their service life, with components that were accessible and serviceable rather than disposable. Many Series 71 engines accumulated over 1 million miles through multiple rebuilds, proving the soundness of Detroit's engineering philosophy. While the Series 71 used dry sleeves, its modular construction still allowed for in-frame servicing and cylinder restoration without requiring full engine removal. In 1957, Detroit introduced the Series 53 as a more compact sibling to the 71, targeting construction equipment, industrial, and marine markets, with later adoption in medium and heavy-duty trucks where space and weight were critical factors. The 53 series maintained the two-stroke architecture and parts interchangeability that made Detroit famous while offering a lighter, more efficient package. The Series 53 displaced just 53 cubic inches per cylinder compared to the Series 71's 71 cubic inches, but it retained the power density advantages of two-stroke design. Available in configurations from 253 to 8V53, these engines could produce impressive power while fitting in applications where larger engines wouldn't work. The mechanical simplicity meant they could be serviced anywhere, and the robust construction ensured long service life even under demanding conditions. The Series 53 used the same unit injector system and mechanical governor as larger Detroit engines, creating familiarity for mechanics who worked on the entire Detroit lineup. The Roots blower was gear-driven and virtually maintenance-free, providing consistent boost regardless of engine speed or load conditions. The Series 53 found particular success in urban delivery applications, where its compact size and responsive power delivery were advantages. Delivery trucks, refuse haulers, and transit buses used these engines for their ability to handle stop-and-go operation, while providing the durability needed for commercial service. The engines could handle the thermal cycling of urban operation better than many four-stroke alternatives. But it was the Series 110, introduced in 1945, that truly demonstrated Detroit's engineering ambitions. This engine expanded Detroit's reach into rail, marine, and stationary power generation applications, where maximum power and durability were essential. Designed as a higher displacement option with 110 cubic inches per cylinder, the Series 110 delivered superior performance in the most demanding applications. The Series 110 was built for applications where failure wasn't an option: railroad locomotives, marine propulsion, and stationary power generation, where continuous operation under maximum load was required. The engine featured the same modular design philosophy as other Detroit engines, but scaled up for applications that demanded more power than the Series 71 could provide. Railroad applications were particularly demanding, requiring engines that could operate continuously for hundreds of hours while providing consistent power output. The Series 110's robust construction and conservative tuning made it ideal for locomotive service, where reliability was more important than peak performance. The engines could handle the shock loads and vibration of railroad service while maintaining precise speed control under varying loads. Marine applications also embraced the Series 110 for its ability to handle continuous operation in harsh saltwater environments. Commercial fishing vessels, tugboats, and offshore supply boats use these engines for both propulsion and auxiliary power, appreciating the mechanical simplicity that made repairs possible at sea. The engine's tolerance for saltwater contamination and their ability to run on varying fuel quality made them popular in remote marine operations. Power generation was another natural application for the Series 110, where the engine's ability to maintain constant speed under varying electrical loads was crucial. The mechanical governor system could hold engine speed within tight tolerances, essential for maintaining proper electrical frequency. The engines could operate continuously for months at a time, providing reliable power for critical facilities. The Series 110 also laid the groundwork for the Series 149, which emerged in the early 1960s. While not a direct evolution, the 149 carried forward the same high displacement, high output philosophy that defined the 110. With a square bore and stroke, redesigned airflow systems, and significantly increased horsepower, the 149 became the engine of choice for marine vessels, mining trucks, and oil field equipment. It modernized the heavy-duty legacy of the 110 for a new generation of industrial power. These three engine families, the 53, 71, and 110, established Detroit Diesel as the undisputed leader in two-stroke diesel technology. The company had created a comprehensive lineup that could power everything from compact generators to massive ships, all sharing the same fundamental design principles and parts commonality that made them economical to maintain and operate. By the 1970s, Detroit Diesel needed a modernized workhorse for on-road trucking and heavy equipment, and the answer came in the form of the Series 92. Introduced in 1974, it was essentially an evolution of the 71 series V-block engines, but with increased displacement, 92 cubic inches per cylinder instead of 71, and a redesigned block for more demanding applications. This new engine line offered more horsepower and torque, while fitting into the same general footprint, making it a favorite for Class 8 trucks, fire engines, buses, and military vehicles. The 92 series gained popularity quickly due to its power-to-weight ratio and aggressive throttle response, which drivers loved. But while it preserved Detroit's hallmark serviceability and performance, it arrived at a time when the industry was beginning to value fuel economy and emissions compliance just as much as brute force. The 92s, especially in turbocharged and intercooled variants like the 8V92TA, were powerful but increasingly seen as thirsty and dirty compared to the emerging competition. Despite its success in the field, the Series 92 ultimately highlighted Detroit's struggle to adapt. It showed how far two-stroke engineering could be pushed, but also how far it had to go to meet tightening emissions and fuel standards. Challenges that would soon force Detroit to confront the limits of its legacy designs. Detroit Diesel's relentless pursuit of technical perfection created engines that were marvels of mechanical engineering, but they were also becoming increasingly impractical for the markets they were supposed to serve. The Series 110 perfectly exemplified Detroit's philosophy of technical ambition, tailored to heavy-duty, non-automotive sectors. Its centrifugal blower for intake air is what made it excel in marine, power generation, and construction. The centrifugal supercharger system provided excellent airflow and efficiency in these settings, outpacing the Roots-type blowers used on other Detroit models in both performance and volumetric efficiency. However, this sophisticated blower required stable operating conditions and specialized expertise, reinforcing the 110's primary fit for those applications where reliability and continuous heavy-duty service were essential. The centrifugal blower system represented Detroit's commitment to technical excellence taken to an extreme. While Roots-type blowers were simple, reliable, and easy to service, the centrifugal system offered better efficiency and more precise airflow control. So, in its element, the centrifugal blower worked beautifully, providing consistent airflow across a wide range of operating conditions. The engineering behind the centrifugal blower was impressive. A precisely balanced impeller that could spin at extremely high speeds while maintaining tight clearances with the housing. The system provided better volumetric efficiency than Roots blowers and was less parasitic on engine power, theoretically making it superior in every measurable way. Detroit's engineers were justifiably proud of this technical achievement. But in highway trucks, the system was too demanding for standard operation and required specialized maintenance that most truck stops couldn't provide. The centrifugal blower was sensitive to speed changes and required precise adjustment to maintain optimal performance. When problems occurred, diagnosis and repair required specialized knowledge that wasn't widely available in the trucking industry. The very sophistication that made the engine superior in industrial applications made it unsuitable for commercial trucking. Truck operators needed engines that could be serviced by any competent mechanic, not systems that required specialized training and equipment. This is a perfect example of Detroit's pursuit of technical perfection that created a solution too advanced for its intended market. This disconnect between engineering excellence and market practicality became a recurring theme throughout Detroit's product development. The company's engineers were solving technical problems that customers didn't know they had, while ignoring practical problems that customers faced every day. The pursuit of mechanical perfection was becoming an end in itself rather than a means to serve customer needs. The pattern repeated across Detroit's product line as the company doubled down on complex, two-stroke designs, while the rest of the industry was moving towards simpler, more efficient four-stroke technology. Detroit's engineers were convinced that two-stroke technology was inherently superior, and they continued refining and perfecting systems that were becoming increasingly obsolete. The company's resistance to four-stroke trends wasn't just technical stubbornness, it was a fundamental misreading of market direction. While Detroit was perfecting the mechanical artistry of two-stroke engines, competitors were recognizing that the future belonged to engines that were cleaner, quieter, and more fuel-efficient, even if they weren't as mechanically elegant. The two-stroke scavenging process that made Detroit engines powerful also created inherent limitations that couldn't be overcome through better engineering. Some fuel inevitably passed through unburned during the scavenging cycle, creating visible emissions that were becoming unacceptable as environmental awareness grew. The blower that provided power also consumed energy that wasn't available for propulsion, affecting fuel efficiency. Detroit's slow adoption of emissions-friendly technology reflected this same pattern of technical excellence becoming a strategic liability. The company's engineers were so confident in their ability to solve problems through mechanical innovation that they failed to recognize when the market was beginning to demand something different. As emissions regulations began to tighten in the 1970s and 1980s, Detroit's response was to try to make two-stroke engines cleaner, rather than to consider whether four-stroke technology might be better suited to the new requirements. The company invested heavily in combustion research, fuel injection improvements, and scavenging optimization, all while missing the fundamental shift that was occurring in the industry. The irony was that Detroit's technical capabilities were more than adequate to develop competitive four-stroke engines. They had the engineering talent, manufacturing expertise, and financial resources needed to succeed. But the company's commitment to two-stroke technology was so strong that they couldn't bring themselves to abandon the systems that had made them famous. The end didn't come with dramatic failures or catastrophic breakdowns. Instead, Detroit Diesel's decline was a quiet fade as their technical brilliance became increasingly irrelevant to market demands. The introduction of the Series 60 in 1987 represented Detroit's belated recognition that four-stroke technology was the future. But by then, it was almost too late. This clean sheet design featured full electronic control through the Detroit Diesel electronic control system, dramatically improved fuel efficiency, and the ability to meet increasingly strict emission standards. It was everything that Detroit's two-stroke engines were not. The Series 60 proved that Detroit could build competitive four-stroke engines when they chose to, but it also highlighted how far behind they had fallen. Meanwhile, rivals weren't waiting. Fleet owners began choosing Cummins engines like the N14 and ISX, not because they were cheaper, but because they were easier to repair, more fuel efficient, and smarter on maintenance costs. One operator put it simply, the N14 is easier to work on and more affordable to fix and rebuild. By the mid-1980s, Detroit Diesel's market domination had collapsed. Market share dropped below 5%, driven by increased imports and ongoing product reliability issues. Former GM division leaders even admitted, in the late 1970s and early 1980s, we were letting bad product out the door. The contrast was stark and painful for a company that had once led the industry in innovation. Detroit's legacy two-stroke engines, which had seemed like marvels of engineering just a few years earlier, suddenly appeared primitive compared to the sophisticated four-stroke engines that competitors were offering. Detroit Diesel's vulnerability was further exposed in 1998, when it became one of 7 diesel engine manufacturers accused by the EPA and DOJ of installing defeat devices. These systems allowed engines to pass lab emissions tests but disabled pollution controls during actual highway driving. The companies paid a combined $83.4 million in civil fines, and committed over $1 billion in corrective actions, including rebuilding engines to cleaner standards and fast-tracking cleaner engine production. While Detroit wasn't the only one named, the scandal added to the growing perception that the company had lost both its technical and ethical leadership.